Good morning, everybody. I know it's weird, day 2 of second semester, and Smith doesn't show up. But I'm not on a beach somewhere. I am sitting at home at a leadership conference that's been on my schedule for about 6 months, so I couldn't just skip it out. So I got time here on a Saturday to prep some notes for you guys, and I want to start by saying this: these notes are review. They are. But I'm begging you not to check out because I'm going to fine tune some things and maybe you'll hear it in a different way than you have before. And so it'll click for you. All the stuff that we're going over, none of it's busy work. We're all going to use it more in this chapter and the next 2 chapters. It all builds. And this spring semester, like we talked about, is almost like an Algebra 3. We did the trigonometry in the fall with all the sine, cosine, and tangent. Now we're shifting into more of the advanced algebra. But you know how algebra is and how math is, it all builds. So today's goal is to bring up some of these old concepts that you've seen before, but hopefully show them to you in a new way. And I'm hoping that you will comprehend them better and be able to apply them the rest of the semester. So that being said, let's first talk about the distance formula and the midpoint formula. Distance formula can be used to find the distance between 2 points, obviously. So let's just start with the formula and then we'll go from there. It kind of looks complicated, the big square root, but the formula is your second x point minus your first x point squared plus your second y coordinate minus your first y coordinate squared. At the end of this video, I have to keep it 15 minutes. We're going to actually derive the distance formula equation, and you can see how it is so simply found on a coordinate plane. And it's very closely related to our old buddy, the Pythagorean theorem. So we'll look at that shortly. And the midpoint formula, you can almost think of it, if you're trying to find the middle point between 2 points, think of it like the average between the 2 points. And so how do you find average? Well, you take your 2x values of your 2 points and you divide it by 2 to find the average x value point. And then if you want to find the y value, let me fix our line here. If you want to find the y value point, then you just add your 2 y values together and average them, and you'll end up getting just like one coordinate as the midpoint. And then the distance isn't a coordinate. The distance formula gives you literally a length of how far apart they are. So let's try it. Let's just pick a random point. Let's switch to red. Let's go right here. Call that point A. That's the point 2, 2. And then let's go over here and make this point B. That's the point 6, 4. So we need to first find the distance between those 2 points. You guys are smart, you can probably already see how we're going to later do, look, you can make a right triangle and we'll do the Pythagorean theorem. But let's just go ahead and use the formula. Let's go ahead and plug it in. So if we're going to use the distance formula, this is the point 2, 2. That's our first x and our first y. This is the point 6, 4, our first x, or our second x, and our second y, excuse me. So when we put it in the formula, we've got the square root of x2, which is 6, minus x1 squared, plus y2, which is 4, minus y1, which is 2. So that is the square root of 6 minus 2 is 4, 4 squared is 16, and 4 minus 2 is 2, 2 squared is 4. So the answer to this is the square root of 20. That is the distance between those 2 points. The square root of 20 is somewhere between 4 and 5, right? So you could leave it as root 20 or you could change it to a decimal. So there's the distance. What about the midpoint between the two? Well, we know what x1 and x2 are. x1 is 2 and x2 is 6. Those added together give us 8. 8 divided by 2 is 4. So the midpoint is 4. See how I did that? Added the 2 x's together and divided by 2. We do the same for the y's. 4 plus 2 is 6. Divided by 2 is 3. So the midpoint is 4, 3. And let's just test it just for kicks. 4, 3. Booyah. Midpoint. So distance is used to find the length of something, right? Sometimes, and I want you guys to be able to apply these to real world questions. The ACT loves a good distance formula question where they'll give you some coordinates of like 2 buildings and say how many miles apart are they, and the fastest way to do it would be to use those 2 coordinates and use the distance formula, right? It's used a lot in triangulation on GPS, like on maps. That's how you find the distance between two areas, is you create the triangle. So distance formula is very useful. And then the midpoint formula is just a takeoff of averaging the two coordinates to find the center point. Very useful in geometry and useful in algebra as well. All right, we got to keep rolling. Slope of a line. Okay, now we're talking about slope. The building block of algebra. And a lot of students, and I want to nip this in the bud now, when I ask them, say, what's the equation for slope? Everybody says y equals mx plus b. And I give them a big, okay? That's slope-intercept form of a line, but that is not how you find the slope. The slope of a line, okay, we know what a line looks like, right? It has a constant rate of change, okay? If this is up 1 over 2, then this is up 1 over 2, up 1 over 2. All the way through eternity. Straight lines have the constant rate of change. And so to find the slope, there's a lot of different ways. You sometimes hear it as rise over run. You sometimes hear it as the change in y divided by the change in x. It's kind of my personal favorite. It's pretty cool when you use that. But what we're used to is a take on change in y divided by change in x. But we actually say the change in y is y2 minus y1. See what I mean by the change in y? Like how much did the two y values change? Divided by how much did the two x values change? That's what we're doing when we're subtracting those. Because to find a line, you need 2 points, just like distance and midpoints. Very relatable. Okay, you need 2 points to find the slope of a line. Can't do it with one. You got to have at least 2. Okay, so if we just make up random points, go here. What is that? 1, 2, 3, 4. It's negative 4 comma 1. And maybe we go down here. 2, 1, 2, 3, 2, negative 5. Well, if we wanted to find the slope between those, obviously it's a negative slope, but let's actually prove it with the math. We do y2, which is negative 5, minus y1, which is 1, over x2, which is 2, minus x1, which is a negative 4. See how that math works out. 2 negatives make a plus. Oh no, my computer just says low battery mode. Let's hope I can finish this video. If I cut out halfway through, you know what happened. So let's finish this math real quick. Negative 5 minus 1 is negative 6, and 2 plus 4 is 6. Of course, I picked one with a slope of negative 1. That's what I get for making up some easy thing. Okay, so that's how you find the equation of slope. I really don't want this computer to die. We're making a move. We're making a move. My charger's in here. All right, I'm back. Relocated. So let's just talk kind of some properties, and then I have to wrap this video up in about 5 minutes or so because I'm on a free trial because I'm cheap. Positive slope, we know what that means. It just means that the line is increasing, right? Slope is positive, the line is increasing. It can be really steep like this. It could be pretty flat like this, but you get the idea. Positive slope means that the rate of change is going up. You're earning money, you're gaining weight. Like, we can model a lot of situations in the real world where something is increasing over a span of time, right? Negative slope then is just the opposite. It's decreasing, and it's visually represented by a downward slope. We always read it left to right. So when you're graphing, you go left to right across the graph to see if it's going positive or negative. We do that because the x-axis follows, starts at 0 in the middle and then counts up. What does a line look like that has 0 slope? Well, I tell students sometimes, like, if you're riding your bike on something and I told you that the ground had 0 slope, then what type of kind of terrain do you think you're on? And if you said a perfectly flat road, you're correct. So a 0 slope is a perfectly horizontal line. Has 0 slope. And the way you would graph that, the equation, let's do it over to the right, is if I wanted to graph a line that went straight through maybe that point right there. That's the point 0, 3. Then I would want to say y equals 3, because what that does is it gives us a line that goes right through where y equals 3. On the flip side, which we're doing next, if you have an undefined slope, that's like if you tried to ride your bike straight through a brick wall. It ain't happening. It doesn't have a slope. It's undefined. It's a vertical line. Okay? Maybe you could ride your bike up the side of this wall if you were in Christopher Nolan's movie Inception and you're in the dream. Maybe you can do that, but not in the real world. And then over here on the right, vertical line, say we wanted to put it through this point, which is the point 3, 0, then we would say x equals 3, and it would make a vertical line. Okay? So vertical lines are x equals, horizontal lines are y equals. We got increasing, decreasing. We're just making our way around the graph. 2 more things. Yikes. Parallel lines. You know what those are? Look like this. Let me switch back to blue. 2 lines that never touch. Yikes. Those are not parallel lines. I'm getting used to rewriting, guys. My finger is feeling better. And so I'm starting to write like normal again. Thank goodness. Parallel lines, they never touch. They have the same slope. That's why they never touch. If they had different slopes, they would touch. And then perpendicular lines, they make a perfect kind of T, like an intersection at a 4-way stop. 90-degree angles there. Okay? And the type of slope that they have are opposite, as in positive negatives is different, and reciprocal, which means the fraction is flipped on its head. So an example, just real quick, if I said that a line had a slope of, remember m represents slope, if it had a slope of 1/3, and I told you to find a line that was perpendicular to that line, then we would know that the slope of the perpendicular one would be negative, and then we flip it, -3/1. So parallel, same slope, perpendicular, opposite, reciprocal slope. And to finish up this video, I want you to see where the distance formula comes from. It's very simple, okay? We are going to treat this coordinate as point number 1. So notice x1, y1. We're going to treat this coordinate as point number 2, x2, y2. And you see over here, remember, our old friend, Pythagorean theorem. So what we're going to do is we technically need to find the distance, right? We need to find this. I'll put a question mark on it. And where it comes from, I want you to see where the distance formula comes from, is you make a right triangle. Okay? Make a right triangle. So what would be the length of this here? This line. Line A, we'll label this C. Line AC. Well, if this is x1 right here, let me use red to help me. If this is x1 and this is equal to x2, then wouldn't this length be the distance of x2 minus x1? Like whatever the distance is between those two? That would be that length. And if we did the same thing going up and down, we know that right here, this is level with y1. Remember, this is the y-axis, this is the x-axis. So this is level with y1, and this up here is level with y2. So it's like, oh, what's the distance between these two? It's your second y minus your first y. So this is the length of this blue vertical line. This is the length of this leg of the triangle. And so how do we find the hypotenuse? A squared, this is A, plus B squared, this is B, equals C squared, which is our distance. And to wrap this up in 20 seconds, if you want to find the distance, you would square root both sides. And voila, what do you have to find the hypotenuse? You have the distance formula. That's where it comes from. Okay? So I wanted you to see that the distance formula is exactly connected to Pythagorean theorem, and it's on a coordinate plane. Okay? The next video, we dive into the 2 formulas for equations of a line. Rewatch this if you please, and I'll see you at the next video.